So, hi everyone. Today we are going to learn this problem called evaluate reverse polish notation. I don't know how it's pronounced, but let me just go with polish. Okay. So what the question says is, you are given a string, okay, array of strings. Sorry, you are given an array of strings tokens that represents an arithmetic expression in a reverse polish notation. Okay. Evaluate the expression, okay, return an integer that represents the value of the expression. Okay, super. So the question is pretty simple, but you are given a string of tokens, array of strings of tokens, and that is represented in reverse polish notation. Okay, let's go with what is this reverse polish thing. Oh, this is the postfix notation. Okay. So let me just open my paint now. So yeah, the reverse polish notation, I don't know what this is, so let me just wait, we don't care about that. But coming to the point, this is a simple postfix notation. Okay, got it. So actually, coming to the basics, right, there are actually three ways of representing an expression. Okay, so suppose if I had to represent 3 plus 4, right, so one way is to do it this way, which we do it from our childhood days, and this is called infix. Why? Because the expression is fixed, right? Okay, because the operator is fixed in between, so that in comes this infix. There is another way of representing this called the prefix expression. So pre meaning before, right? So you can represent 3, 4 and plus here. This is called pre, and naturally the fix comes off after it. And there's another way to represent this. This one is called the postfix expression. So post the operator, you are representing it, and this is why it is called the postfix expression. Okay, so there are actually three broad ways of representing an expression, and you might wonder, like, why the heck did someone come up with prefix and postfix when infix was working fine? Well, so if we go to the Wikipedia page here, let me just zoom in a little bit, and if we see the practical implications of why someone came up with this notation, so it says, in comparison with polish notation with algebraic expressions, reverse polish has been found to lead to much faster calculations. Why? How can storing it differently improve calculations? Well, this is something, you have to deep dive into. So the problem is very easy, so spoiler alert, but that's the reason why I'm just diving deep into all these concepts of what an expression is and all that stuff. So how can storing it in a different format speed up calculations? So this is a very good idea. So I'm going to start by taking this example here. So let me just copy it here first. So we have 2, and then to this we are adding 1, and then to this we are doing a star or this multiplication. Okay, and then followed by a 3, followed by this thing. Okay, so yeah, this is the expression that we are given, and now we need to evaluate this. Okay, so how are we going to do? So normally calculators in olden days, what they used to do, they used to see the first parenthesis, do the parenthesis comparison, like, so first you see this thing, right? So open parenthesis, push it into the stack, again, closed parenthesis, open parenthesis, again an open parenthesis, then you see a 2, great, okay, then you see a plus, okay, then you see a 1, okay, then you see a close parenthesis. So when they see a close parenthesis, it means that this expression has to be evaluated first, because in the BODMAS rule, B is given the first importance. So then it removes this, then it removes this, then it removes this. Okay, and then what it does is, after removing all these 3, the result is finally stored into the stack. So 3 is stored again, and then it sees a star, so it pushes this star again, then it sees a 3, then it pushes the 3 again, then it sees another parenthesis, so this time again it will pop both of these, and it pops both of these, and then it evaluates the inner expression, which is 9, and then it sees another closure, right? So at this point you don't need to bother about anything, and your this thing represents the value for this. So this is how the this is how infix expressions were working. So someone came up with this postfix notation, or to our problem which is called fancy name reverse polish notation. So what this says is, don't store it this way. Let's make the job for compilers or these so-called language translators, which translate the assembly language, which translate our high-level language to the low-level language. Let's make their life easy. So what they came up with was, so don't store it that way. Whichever has to be first executed, store it like this. So you want 2 plus 1 to be executed first, so then convert that first to the infix expression, sorry, postfix expression. Then you want this one followed by this one to be executed next. Okay, so here is my first operand, here is my second operand, and a star followed by it. Fine. And what else do you want me to execute? That's it. So this is how you convert an infix expression to a postfix expression. And if you notice, this is going to improve the performance of the calculators very fast. How about, they'll see a 2, push it, 1, push it, plus, just add them, plus, so that's how they traverse it. They see a plus, so just add them and push it back, and then you see a 3, okay fine, I don't care. Then you see a star, so then pop them up, and push a 9 into the queue, into the stack, sorry. So this if you observe, is quite faster than compared to the parenthesis way of giving the expression in this infix notation. So that is why this is considered to be more performance effective than compared to that one, and that is what Wikipedia also quotes here. So it says, in comparison with the reverse polish has been found to lead to faster calculations for 2 reasons. The first reason is that reverse polish calculators do not need expressions to be parenthesized. So they too fundamentally highlight this, right? Reverse polish calculators do not need expressions to be parenthesized. Yeah. So fewer operators need to be entered to form typical calculations. Yes, right. Here, if you think with these, if someone has to enter even the parenthesis and all, so he would have to enter 1, 2, 3, 4, 5, 6, 7, 8, 9 characters to get his job done in a calculator in olden days, and fundamentally computers were invented for that. But in this case, this I have just given it for our understanding, but even technically, even this also won't come. So all he would have to give is just 1, 2, 3, 4, 5. So here, I don't know, I forgot the number here, but here he has to give 5, which is considerably less. Okay, let me just count it again. 1, 2, 3, 4, 5, 6, 7, 8, 9. So, which is considerably, better than this one. Like, imagine if the expression is much complex, then you would have more and more parentheses, and like you could even parenthesis this one, right? So you can parenthesize, let's say, how can you parenthesize this? I don't know. You cannot parenthesize this anymore. But you get the point. If the expression is very complicated, then your parenthesis could end up, and you might end up storing large memory in just this expression. So this is a small behind the scenes as to why someone came up with a postfix notation of storing it. Prefix notation, I'm not aware of why this has been invented in the first place. But anyhow, some dumb guy without sitting quiet in his home would just come up with a prefix, because anyhow infix is there, we're writing in our books, postfix is there, it's used by calculators, so let's come up with a prefix notation so that people out there, just for the name of a research paper, he would have come up with this thing. But no hate, so let's just see how we are going to solve this. So I have clearly shown you the implementation of this by just explaining you what this expression does, right? So I'll just how this is evaluated. So let's just see how this works, and I'll just trace it out and we can get it done. So I've actually coded this and submitted it on LeetCode. So mine got accepted, so that's why I'm here making a video for you guys. So first, this won't be given to us. We'll be given a postfix expression, right? So you'll not be given that. You'll rather be given 2, 1 plus 3 and a star. Okay. So first time, whenever you see a number, just push it into your stack. don't bother about anything. Number, push, that's it. Second time when you see a 1, just push it again into the stack. Next time when you see a plus, don't push it. This is a blunder, okay? Don't push it. What are we doing? Whenever, if we keep on storing something, when are we going to pop them and get the result? So whenever you see a plus, it means a plus operation has to be performed on these two elements. So now we are going to pop these two elements. Oh, this was our stack initially. So we are going to pop these elements first, and then we are going to push the result of this. Why do we have to push the result? Remember, man, we are not done here. We have still this part to evaluate, and this result has to be propagated to this part. So that is the reason why we store this 3 into the stack. Okay, so this is the result of this part of the expression. Now we have a 3 again. So this time 3, we push it. So number, just push. Then we find a star. So first we were here, then we came here, then we find a star. So we perform the star operation on the two elements, like the two elements, because the first element will pop once, will get 3, pop twice, you will get 3, perform the operation 9, then again move forward, you don't find anything. So whichever is there in your stack is going to be the answer of this expression. It's a very simple question. I don't know why LeetCode came up with a medium tag to this. Okay, but anyhow, let me just reset this, and we are going to try coding it out. So yeah, I'm going to code this out along with you, so that any errors we make, we're going to make it jointly. Okay, so okay, let me just open my file here. So I do it in IDE before I do anywhere else, because you know it's kind of safe here, but this is a very bad practice. Never just repeat it doing in an IDE. Okay, so let's just start. So I need one utility function which is going to tell me whether a number is an integer, or whether a number is a number, or is it a special operand kind of thing, right? So what I'm going to write this thing called isNumber. Okay, this takes an string str, and this is going to do something magical. So integer, now let's say this returns an integer number is equal to null. Okay, fine. And now I'm going to try doing something, and this is where your knowledge of try and catch plays out. So I'm going to try something. What am I going to try? Number is equal to number. Okay, integer dot parse. Sorry, why did this? Int, and I'm going to pass it this str. Notice that whenever your str is some special character other than a number, this gives you an exception. This says number format exception something. You get some kind of an exception like that, and that is when this catch block is triggered. And in this case, I just return null, telling your number is not proper, or else I would just return the number finally. Okay, so return the number. So this is a very simple code to just say, I don't know if this is correct or this is how you do it, but I am going to follow this way of doing it. Okay, then comes the other part. Now we will do another for loop which traverses the entire array. Okay, simple. Then we are going to say, if we are going to capture this current string into our a variable and tokens of I. Now I'm going to ask a question. So if let's say integer current int is equal to isNumber token of current string, let's just pass it here. Okay, so I'm going to ask, is the current, so if I get null, if this is not equal to null, if the current int is not equal to null, what does that mean? That means it's a number, right? So what do we do for numbers? We have seen here, right? Sorry, we have seen here, right? Any number, we don't care what is going to happen next, we just push it into the stack. So all, okay, so we forgot to declare our stack here. Oh, come on. Stack of integer, 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 let's import this, stack, new stack. Okay, and here we are going to do stack dot push. Okay, push what? Push the current item, and anyhow this is going to be integer, so we have the current item. Now what if this is null? What does this mean? Null means this is a string, null means this is a special character. Okay, so string. So now we are going to do a for loop, or we are going to do an else if condition followed. Okay, wait, yeah. So one second, I just wanted to continue this. Let this execution not come out till this point once this is executed. Okay, let me do another if condition. So if it's an integer, we don't come here, but if it is not, if the current string dot equals ignore case to a plus, so what do? If it's a plus operation, if so whenever you find this plus operation, or here we found out a plus, so at plus operation, what did we do? We removed the two elements from the stack, and then we just did the operation specified, right? So here we are going to do first operand is equal to stack dot pop, then second operand stack dot pop, and then you are going to stack dot push, perform that operation on second operand, because the order gets changed in the stack, right? So you have to do this. This is a good logical part. So here actually you had two, you need to do 2 plus 1, but now if you remove the same order in the stack, right, actually you'd have 2 stored here and 1 stored here, but when you get it out, you get 1 first and 2 second, but the expression is not this. You wanted to do 2 plus 1, that was your intention. So this is a good logical step here. Might be this is why they would have given this a medium problem, but I don't know. This is actually a pretty easy problem. So current string dot equals ignore case. What if this is equal to minus? Then the same code, just copy pasting. Okay. Then we go for a minus. Then same code I'm doing it. Okay, so what if it is equal to a divided by, a multiplication? Then we are going to multiply here as well. Multiply here as well. What if it is equal to a divided by? We're going to divide it here as well. Now if you notice, at the end of this for loop, right, when all our tokens are being processed, that is when we have one element in the stack, which is the result. So I'll just pop that element as well, and I'll just return it. So this is a very simple implementation of how our thing should work. So let's hope for the best and submit it. I don't know if any errors would come by, then I would have to solve it. So yeah, copy this, come here, paste it off. We did not copy the isNumber method. I don't know if this is the right way to process. Well, this works in Java, but I don't know how the guys from other programming languages would try it out. So I don't know. Like, you can let me know if there's any any other programming language and you have a much better way. Exception. Finding something from exception is a way, like hitting someone and asking him a question. So there's actually a wrong way of doing it. But I don't know, for the time being I found it worked as well. So if it doesn't work, then I would have to think of a new approach. But yeah, so it passed these test cases. Let me try submitting it. If this gets submitted, then let's see. Yeah, why is it taking this much time? Yeah, it got accepted as well. Yeah, so this is how, but see, my question is very, very less effective. So it's just 0.3% of solutions used 18 milliseconds of time. In fact, there are people who were able to do much faster than me. Okay, how would have they come up with an approach? What kind of an approach would they follow? Feel free to tell if you have any, if any violations are being done by me in these videos, so that we could just, so that I could improve. Okay, so yeah, that's it for today's video.